Welcome back. In this video, we're going to take a look at a couple of examples of using the integration by parts method. And as I discussed in the last video, we use these memory mnemonics up at the top of the page to help us decide what to pick U. And so we want to just go down the list, and whichever function comes first, we're going to use that for U. So we have a polynomial function here, x squared, and then we have a trig function, sine x. Since polynomials come first on the list, we are going to let U be our polynomial function of x squared. So we're going to let U equal x squared, which means dv must be the leftover part, which is sine x times dx. And then for the u, we're going to find what du is. So if u is x squared, then du is 2x dx. And then for dv, we're going to integrate both sides. So if dv is equal to sine x dx, the integral of dv is just v. And the integral or antiderivative of sine x is negative cosine x. So we can go back to the integration by parts formula that's in the theorem that we discussed in the last video. It says that the integral of u dv is equal to uv minus the integral of v du. And we now know all of those parts. We just did them here in this box. So let's see how this works. So I'm rewriting my integral. I have the integral of x squared times the sine of x dx. And of course we can see those parts that we just decided on. We can see that this is our u. We can see that this is our dv. And so we know by the integration of parts formula that this should be equal to u times v, should be equal to x squared times v, which is negative cosine of x, that's u times v, minus the integral of v du. So v is, again, negative cosine x, and du is 2x dx. So again, let's label these parts just so we can see exactly what's going on. This is u, this is v, minus the integral of v du. And just to kind of clean this up a little bit, I always think it's better if we clean things up, make them look nicer. So this is going to be negative x squared times the cosine of x. And then notice we have minus this integral, which also has a minus in it. So let's just make the integral positive. I'm going to move the constant of 2 out in front, and we're left with the integral. I'm going to write the x in front of the cosine x dx. And so things are getting a little bit simpler, but we still have, in the second part of this result, we still have a function times a function that are unrelated. We still have a polynomial function x times a trig function cosine. So we're going to have to use the integration by parts method one more time, and that often happens. We can do that. But we're just going to do it on this part that I'm about to box here. We don't have to do it on the whole thing. We're just going to do integration by parts again. So we're going to do integration So we did it the first time, we're going to do it again. Again, we're going to let the polynomial function u, or be our u, so u is going to be now x this time, and that leaves dv as being cosine of x dx. So what would du be? Think about that for a second. Du would be the derivative of x, which is 1, times dx, so we can just say it's dx. And then what would v be? Yep, take the antiderivative. So the antiderivative of cosine is sine. And then we go through integration by parts one more time. So first part is going to remain unchanged. So we have minus x squared times the cosine of x. And we have plus 2 times our integration by parts that we just wrote out. So again, we have u times v. Well, u times v is going to be x times sine x minus the integral of v du. So minus the integral of sine x, that's v, and dx, or du is going to be dx. And now, notice our new integral is something that's just a single function. So integration by parts worked out the way we wanted it to. I'm going to go ahead and integrate that. So we have minus x squared times the cosine of x plus 2. We have x sine x minus the antiderivative of sine, which is negative cosine x. And we have our constant of integration on the end here. So we can distribute the 2. We have negative x squared cosine x plus 2x sine x, distributing the 2, also 2 times, this is a negative times a negative, so that's a positive. Positive 2 cosine x plus c. That's our final answer. And that's our first example of using the integration by parts method. In this video, let's go ahead and do one more. So if we look at example 2, what are we going to pick for u? We have 2 types of functions. What are these types of functions we're dealing with here? So we have a polynomial function and a log function. What are we going to pick for u if we have a polynomial and a log function? Well, hopefully you chose your u to be the log function. That's what, if we go back and look at Lipit, log functions come before polynomial functions. So if we let u equal the natural log of 4x, and that leaves dv as being x squared dx, then what would du be equal to, and what would v be equal to? I'm going to let you go ahead and do that on your own. Go ahead and pause the video. Alright, so you should have got du as being 1 over 4x times the derivative of the inside. This is a little chain rule here, which is 4. And that actually then simplifies down to 1 over x. I left the dx off, so 1 over x dx. Integrating the right-hand side, we get 1/3 times x cubed. And so now we can go ahead and work out our integration by parts. I'm going to rewrite this. We have the integral from 1 to 2 of x squared times the natural log of 4x dx. And this is equal to u times v, or the natural log of 4x, that's u, times v, 1/3 x cubed. We're going to evaluate this from 1 to 2. Then we have the second part of our integration by parts. It's the minus the integral from 1 to 2 of v, which is 1/3 x cubed, times du, which is 1 over x dx. And then let's clean this up a bit. So we can move the 1/3 out to the front. X cubed times the natural log of 4x, evaluated from 1 to 2. And then this is the nice thing about why we want to let u be natural log. When we take the derivative of a natural log, we get x involved, and the natural log goes away, so 1 over x, and that 1 over x is going to simplify with the x cubed, making this an x squared and canceling that out. And so this integral simplifies down nicely. If we pull the 1/3 out, we get the integral from 1 to 2 of just x squared dx. We go ahead and evaluate this first part. We have 1/3. We plug in 2, we get 8 times the natural log of 8 minus, what's that, natural log of 4. Then we have minus 1/3. Antiderivative of x squared is x cubed over 3. And actually, let's make that, because 1/3 times x cubed over 3, that's going to be 1/9. So let's make that 1/9 x cubed, evaluated from 1 to 2. So just using log properties, we could simplify this. We could say that this is the natural log of 8 raised to the 8th power. Move that power to the end there, minus the natural log of 4. And then evaluating the second part, we have 1/9 times 2 cubed minus 1 cubed, or 8 minus 1. So this is 1/3 times the natural log of 8 to the 8th power over 4, minus 8 minus 1 is 7, minus 7/9. This is about, do the calculation here, it's about 4.31. All right. And that's going to cover it for example 2. So you've now seen one example of integration by parts with a definite integral and one with an indefinite integral. I'll see you in the next video. Thank you.